To find the domain of a function, we want to think about what values of x would or would not make sense to plug into that equation. Things that could go wrong are, for example, we want to make sure we don't take square roots of certain numbers. We want to make sure there are other numbers we don't divide by. So let's take a look, and as we do this, we'll write our answers both in set and interval notation. I'll show you both. I don't really care which one you use. Sometimes one is easier than the other, so we'll see some examples of that. So first up, let's start with something quadratic. Anything that's quadratic or linear or a polynomial, there's no restrictions on your domain. X can be anything. It doesn't matter what we plug in for x. All we're doing is squaring it or multiplying it by 5. Nothing can go wrong if we plug in a real number. And so my domain is everything. And so what I'm going to do in set notation is I'll use brackets always for set notation. I'm just going to say that the domain is all reals. X can be anything we want it to be. As far as interval notation goes, we want to say what's the smallest x could be and what's the biggest x could be. Well, since there's no restrictions, if I'm thinking on a number line, x could be as small as I want it to be. So in math, we're going to say, well, that's negative infinity. I can go as far back as I want to. As far as the biggest x can be, I'll use a comma to separate. The biggest x can be is, again, infinity. I can make x as big as I want it to be. And I'm going to put parentheses around this to indicate that I can't quite ever get to infinity. I can get close, but I can't get there. So either of these would be ways to express domain of this function. The first with brackets is an example of set notation, and then this down here is interval notation. Okay, not very interesting, so let's try one that's a bit more complicated. This time I've got a denominator with an x in it. Well, first of all, the numerator doesn't matter. We don't care about that when we're finding domain. We just want to worry about the bottom, and the number we never ever want to divide by is 0. And so what I have to think, it's not that x can't be 0, it's that I don't want the denominator to be equal to 0. So this is going to be the equation I want to solve, or I guess the not equation I want to solve to figure out what my domain is. And so I'm going to solve this like I would if it was just a regular equal sign. I'll add 4. And so x squared can't be 4. And if I take a square root, I learn that x can't be 2. But remember, when you're solving with square roots, there's two possible answers. There's positive 2 or negative 2. Those would be the really bad numbers to plug in for x. And if you think about why, well, if I did 2 squared and subtracted 4 from that, I'd end up with 0, and I can't divide by 0. So that's the rule. Let's go ahead and write that with fancy math notation right now. Set notation is going to look like this. I'm going to say, since this is domain, the variable I'm working with is x, and then that vertical line, which means such that. So x such that, and then let's write our rule. Our rule we just discovered was that x cannot be equal to positive or negative 2. So there's my domain in set notation. Interval notation is kind of annoying to do for this problem, but I'll do it just so you have an example of it. Sometimes it's easier to look at a graph too, and I don't want to do that right now. So for now, let me just kind of show you what interval notation would look like, though I would definitely stick with this. Interval notation is going to go like this. Everything from negative infinity all the way up to negative 2 are going to be okay to use. Any number in between there is going to be fine. However, I can't use negative 2 because that would make a denominator of 0, so I use parentheses. Well, also, anything between 2 and negative 2 would also work. Or anything between negative 2 and positive 2 would also work. I put this little U-shaped symbol, which means union, basically means and for math. But there's one more interval this works for, so I kind of ran out of space, but this should be next to it. Also, everything from 2 then forwards to positive infinity would also work. Like I said, interval notation's not very nice for this problem. I would probably just stick with set notation for something like that. Alright, moving along. Let's take a look at this example. Now I'm dealing with square roots. I want to think, what numbers do I want to or not want to take square roots of? And I never want to take square root of something negative. I'd get an imaginary answer, and those won't show up on graphs. So when you're dealing with square roots, I want to, oops, that's not what I wanted to do. I want to make sure that what's underneath that radical is greater than or equal to 0. It's just a fancy way of saying positive or 0. 0 is fine because I can take the square root of 0. Okay? And then let's solve this and see what our domain's going to be. So I'll add 3t to both sides and then divide both sides by 3. So I end up with, if I switch the order of this a little bit, I end up with t has to be less than or equal to 4/3. That's my domain. So let's go ahead and write that in fancy math notation. So set notation uses the brackets. I'm going to start with, usually I start with x. I'm actually going to use t this time because that's the variable they gave me, although that's not a huge deal. So t such that, that vertical line, and then write your rule. t has to be less than or equal to 4/3. If I plug in anything bigger than 4/3, I'd end up taking a square root of something negative, and I can't do that. Let's talk about interval notation. T has to be less than 4/3 or equal to it. So at the smallest t could be, well, I could make that as small as I want it to be. It just has to be not bigger than 4/3. So I can go all the way back from negative infinity, and then the biggest it can be, well, it's 4/3. I just said I have to be less than or equal to 4/3. Now here's where it's a little, not really tricky, but again, we want to be careful. This time, I'm allowed to be equal to 4/3. It's fine. I said t had to be less than or equal to 4/3, and so I'm not going to use a parentheses this time. I'm going to use that square-shaped bracket to show that 4/3 is going to be okay. So once again, there's both ways to write the domain, in set notation and interval notation. Alright, and then we got one last one I want to take a look at. This time we want to be very, very careful because there's a couple things going on. Firstly, I don't care about the numerator, remember, not for domain. So all I want to make sure, well, I'm dealing with a square root, so okay, I'm thinking already, just like last time, my x minus 1, what's underneath the radical, has to be positive. It has to be greater than or equal to 0. But we have to be really careful because this time there's a bit of a trick to it. Not only do I have to be greater than or equal to 0, this time, can I be equal to 0? And even though it's a-okay to do the square root of 0, remember where that's located. It's still in the bottom of a fraction. And so this time, I know it's tricky, but this time it's not that x minus 1 is greater than or equal to 0. It's x minus 1 is just greater than 0. Because if this part came up 0, I'd be dividing by 0, and that would be really bad. And so this time, when I solve this inequality, I get x is greater than 1. For my domain. So if I write that in set notation, once again, those brackets, x such that, and then write your rule down. We just discovered it's x has to be bigger than 1. As far as interval notation goes, and again, sometimes interval notation is easier to see if you're looking at a graph, but we'll try to do it without it. The smallest x could be, since I said it has to be greater than 1, well, the smallest it could be is 1. The biggest it could be is, well, infinity. As long as I'm bigger than 1, it's fine. I'm going to include the parentheses around the infinity side because I can't ever quite get to infinity. And the question is, what do I do on the left? Can I be equal to 1 or not? And we discussed at the beginning, being equal to 1 wouldn't be good enough because it would end up dividing by 0. And so this time I need to use a parentheses to say I can get really close to 1, but I can't quite be equal to 1. It won't work.